Okay, so rationalizing the denominator. Essentially, a simplified answer cannot contain a radical in a denominator. So remember that all answers are supposed to be in simplified form. So a simplified answer cannot contain a radical in its denominator. And so in order for us to get rid of the radical in the denominator, we have to rationalize. So essentially what we're going to do is we're just going to rationalize by multiplying the denominator and numerator by the radical in the denominator, in the given denominator. So 7 over the square root of 12x. So on this particular example, the denominator is the square root of 12x. So you can actually simplify the square root of 12. So you can choose to do that before you rationalize, or you can just go with your rationalization, which is to multiply the numerator and the denominator by the given radical that's in the bottom already. Because what we're doing is we're trying to get rid of the radical in the denominator, and this is where that rule of square root of a times the square root of a automatically gives you a comes into play. So this is what happens. People don't want to learn the rules for math, but the rules in math help you be able to do the problem easier and understand what you're doing. So here I can multiply the top and the bottom by the square root of 12x. The top will just give me square root, 7 times the square root of 12x, and the bottom, because I'm going to apply this rule, no, I'm not going to do square root of 144x squared. You can, but I'm not going to do that because I'm going to use the rule so that I know that this is just going to be 12x. So if you choose to multiply it, that's fine. Then you have to take your time to simplify it, which is still going to end up at a 12x. So when I look at this problem, I have gotten rid of the radical in the denominator, but I still have to simplify the square root of 12x because that's not simplified. So 12. So I would get 7 times 2 square root of 3x all over 12x. So you can multiply or you can reduce right now. So what I mean by that is the 2 and the 2 inside the 12 can cancel, which will leave us with 7 square root of 3x over 6. Done. Or we had 14 square root of 3x, right? So if we didn't cancel out, we would have had a 7 times a 2 over a 12x. So now we reduce 14 over 12. They both divide by 2, which would still leave us with what? 7 over 6, and then square root of 3x. So that's rationalizing. So you multiply the numerator and the denominator by what you see. Oh yeah, there's an x at the bottom. So 7 over 3. So 7 square root of 3x over 6x. Okay, so we don't want to forget our x. Hold up, I'm looking for another problem. So then we have square root 29x over 13y. So our directions tell us to rationalize. So the first thing is, when you have one big square root, you can always rewrite it as the square root of each component separate. So the numerator is under a square root, and then the denominator is under a separate square root. So my goal here is to what? Rationalize. So I'm going to multiply the top and the bottom by what's in the denominator. So the square root of 13y. So 29 times 13. We need a calculator on this, which, hold on a second, let me get it. So square root of 377 over 13y, right? Because I know square root of 13y times square root of 13y is just 13y. Because of the rule, square root of a times square root of a is always equal to a. So the square root of 377xy, because I forgot there was variables here. So 377 does not simplify at all. So this would be my final answer. Done. All right, let's look at this one. Square root of 36 over x. So what does that mean? It means the square root of 36 over the square root of x. Well, the square root of 36 can simplify, so I can just write 6 over the square root of x. So what's wrong with this problem? This problem needs to be rationalized. Why? Because I cannot leave a square root in the denominator. So there can be no simplified answer that contains a square root. So what am I going to do to get rid of it? I'm going to multiply the numerator and the denominator by the square root of x. So when I do that, the top is going to be 6 square root of x, and the bottom is just going to be x. X and square root of x cannot cancel each other out. Okay, that's not an x, it's a square root x. So please don't get it confused with your chapter 7 material or previous material, right? So you can't cancel those. You have to just leave it as it is. So that is rationalizing. Now, those are rationalizing when we have a single term in the denominator. What about when we have multiple terms in the denominator? So let's look at that. So here we have 6 over 3 minus the square root of 11. So what's going on in this problem is this problem is not considered simplified because there is a square root or a radical in the denominator, and there can be no simplified answer that contains a radical. So we're going to have to multiply by what is called the conjugate. So conjugates are basically binomials that are the same binomials with different signs. So that when they multiply, they just get rid of the middle term. So a squared minus b squared. So the conjugate would be a plus b, a minus b. So let's separate from this given problem. Let's say you have x plus 4. The conjugate of x plus 4 would be x minus 4. Let's say you have square root of x plus 3. The conjugate would be square root of x minus 3. So looking at this given problem that I have here, we have 3 minus square root of 11. What is the conjugate? 3 plus the square root of 11. So we multiply the numerator and the denominator by the conjugate. So just like in the previous examples, when it's a single term, we multiply the numerator and the denominator by what we see. So now we are going to go ahead and multiply this out. Put your parentheses, because if you don't, you will not distribute and you're going to get it wrong. We have to distribute here. This is a single term that must multiply to everybody at the top. So we would get 18 plus 6 square root 11 over. So in my bottom, because it's conjugates, the conjugate rule says you don't have to distribute the whole thing out, because when you multiply conjugates, the middle automatically cancel each other out. So you can really just do first times first and last times last. So 3 times 3 is 9 minus square root 11 times square root 11 is an 11, because I know square root of a times square root of a is a. Again, if you choose not to use the shortcuts, that's fine. So the long problem would have been, I'm going to just show it to you. It would have been 9 plus 3 square root 11 minus 3 square root 11 minus square root of 121. So 9, these two would have what? Canceled out. Minus square root of 121 is 11. I'm still getting 9 minus 11. So you choose what works best for you. 18 plus 6 square root 11 over negative 2. So my negative 2 can divide into each one of my terms to give me a negative 9 minus 3 square root 11. Problem done. And that will be it. Now, on my math lab, sometimes they write it in the factor form, but it wouldn't matter. Your answer would still be correct in this format. All right, let's look at another one. So on this particular problem, we are looking at the denominator because we have radicals present and we can't have a simplified answer with radicals in it in the denominator. So we're going to multiply the top and the bottom by what? The conjugate. So the conjugate here would be 6 square root of 2 plus square root 10. So you multiply by exactly what you see in the denominator, except the sign in the middle is going to be changed. So put in your parentheses because what are you going to need to do? Distribute or FOIL it. So at the top, we got to distribute through. Okay, you cannot apply the shortcut. You can only apply the shortcut to the denominator. So we would get 18 square root 4 plus 3 square root 20 plus 6 square root 20 plus square root 100. And I'm just going through the whole thing. And then at the bottom, I can apply my shortcut, which is first times first, last times last. So 36 times the square root of 4 minus a 10. So 18 times 2 plus 9 square root of 20 plus 10 over 36 times 2 minus 10. So 36 plus, so square root of 20 can break down. So 18 square root of 5 plus 10 over 72 minus 10. So 46 plus 18 square root of 5 over 62. So 46, 18, and 62 all share a 2. So I'm going to reduce this. So if I divide 2 into everybody, this will become 23, 9, and 31. So 23 plus 9 square root of 5 over 31. And that would be the final answer. So is this process, right? Use your calculator. So I did everything out for you so that I only used a shortcut when I did first times first, last times last. And then I still broke it down piece by piece. So if you know the square root of 2 times the square root of 2 is just 2, you could have just gone straight to 36 times 2, right? So you have to get comfortable in your process so that you can work it correctly. And that is how we rationalize using the conjugate. So when we have more than one term in the bottom, we have to be able to rationalize it by multiplying the numerator and the denominator by the conjugate.